Hi folks, short questions here, 2018. Question 1 I'm going to kick off here. So we've been asked to finish out this bicycle shelter and there's 5 bicycle stands in there and I'm just going to draw one of them and you will be able to draw the other 4 after that, okay? So the first thing we're going to do is work on this. So there's the base coming out here and the top is going up as far as there. A height we will need is this height here of this point. Okay, and we can get that on our compass. And we'll just step it off over here. Now we'll run it across because you'll need that height on the other 5 as you're going along. I'm just going drawing one as I said though. Now that is how you draw one. So you will be able to draw the other 4 now. The last thing I'm going to do is I'm going to finish out this, the main stand, okay? Now part B in this question then asks, a line joining Y to B represents the straight line path of a football. Show the point of impact of the ball with the glass roof in the axisymmetric view. So there's Y to B. We can see here is the point where it hit the roof. And if we redraw Y to B over here, now the point must be somewhere on that line. If we just get our set squares down that point there, and that is the point there that they're looking for, where the ball hits the roof. And that's question 1, folks. So here is question 2, and it's a skew line question, and they do love these for the short question. So part A, determine the projections of the shortest horizontal distance between the skew lines. Okay, so we'll start off there. So I'm going to take a level line from B and I'm going to slide over CD to A, and I'm going to call that point E. So that guy there is parallel to that guy. Now E must be somewhere down here. And again, we'll slide over CB to hit A. Again, that guy parallel to that guy. That finds us E. And so we're making a plane that contains one of the lines and has an edges parallel to the other one. So we need to do that. Now, when you get that true length line, we're going to look along it. Now 2 views back, so we're getting all our distances from the elevation. Now you could measure off a fourth point. I never do that. I just, because they have to be parallel, so it'll be the same thing anyways. So we'll join this guy over now to hit B. Those, they're the two of them perfectly parallel. Now, when it's the shortest horizontal distance, that means you look in along here at the ground line. And the reason for that is we have to end up with a line that will come down here that'll be parallel to this XY line, because 2 views back, the line would be, that means the line will be parallel up here as well. Now for this view, 1 view back, 2 views back. So measure from X1, Y1 back. That's the point we're looking for. We're going to bring it down there. I'll just put this guy in color. Now we're just bringing back through the views. Now you can run up the other point if you want, or you can just make it horizontal, because it has to be a horizontal line. And that is part A of the question there. Part B now asks us, determine and indicate the distance from this line to the horizontal plane. Okay, so you can measure off there, or you can measure off here. So just draw a little line out there. That is the height, and it says indicate, so I'd write it down. So I make it there to be 27 mil. Okay, that's question 2. Now, question 3, folks, and part A says the curved support pillar is based on a parabola which is inscribed in a rectangle V. V is the vertex and P is the point on the curve. Draw the parabola. Well, I had the box given, so if you'll forgive me, it was so basic, I just went ahead and drew it. I don't think you needed to see it, but obviously if you have 5 divisions this side, as we do in the one already spaced out for you there, now I had to use a ruler and sliding set squares to space this out into 5 equal sections as well. Obviously it's 5 this side, it must be 5 this side. and you get your points and you draw in your freehand curve. Part B, so it says F is the focal point of a parabola. The point P is anchored to the bridge by 2 cable stays. The line PF is one cable. Okay, so PF is a cable. The second cable there is inclined at 25 degrees to a tangent P. Construct the tangent at a point P. Well, there's different ways, as you know, with these, if you look back even at your book, there's different ways of constructing it. But one way of constructing a tangent onto a parabola like so, and I'm just going to go through one of them. One way would be to go ahead and to bisect that angle there. So I'll do that quickly with my compass. Now, if you knew, that would be heading on there to the left, that line. Sometimes in the book you might see them drawn with to be going as far as the directrix. But we just need to draw in a portion of that line. So I'll just bisect this angle. This is your tangent here. Okay, that's your tangent. And it says then the second cable is inclined at 25 degrees to the tangent. Okay, so we'll get our protractor, throw it on the tangent there. And 10, 25. So that is your second cable stay. Okay. Question 4. The graphic shows a Spidercam used for aerial coverage of sports events. It is supported by 4 cables. The drawing shows the projections of these cables. So part A, find the dihedral angle between the planes OAB and OAD. Well, I've coloured them in just to make them stand out there. So here we have the line of intersection OA. So our first job will be to go and looking at this to get the true length. And of course, we'll need to take 1 point from each plane. So we'll be taking D and B along with us. Get our heights and elevation, of course. One view, new view, 1 view back, 2 views back. And there we have the true length now of the line of intersection. Next thing we do, we look along this to see it as a point. For the next 2 Y2. New view, 1 view back, 2 views back. And as I always say, you know you're measuring off the right XY line because it's parallel to the line of intersection. So A. and that is B down here then. And there we have our dihedral angle. Now, part B asks us then, determine the angle between the cables OA and OB. Okay, so that's all happening on this orange plane here. This line here is an edge view of that plane, okay? So if we look in at this, we'll see its true shape. Set in X3, Y3. Now, new view, 1 views back, 2 views back. So that's the true shape of the plane OAB. And that is the angle between those two cables, okay, that they are looking for. So that's it, folks. That's the short questions for 2018. Hope you found it useful. Take care. More videos to come soon.